Welcome, class. Periods of Western astronomy. Western astronomy divides into four periods: prehistoric, before 500 BC, classical, 500 BC to AD 1400, and Renaissance, 1400 to 1650, modern, 1650 to present. Ancient Greek astronomers, through the use of models and observations, were the first to use a careful and systematic manner to explain the workings of the heavens. Limited to naked eye observations, their idea of using logic and mathematics as tools for investigating nature is still with us today. Their investigative methodology is in many ways as important as the discoveries themselves. Early ideas of Pythagoras. Pythagoras taught as early as 500 BC that the earth was round, based on the belief that the sphere is the perfect shape used by the gods. Early ideas of Aristotle. By 300 BC, Aristotle presented naked eye observations for the Earth's spherical shape. Shape of Earth's shadow on the moon during an eclipse is to your left. Early ideas of Aristotle. He also noted that a traveler moving south will see stars previously hidden by the southern horizon. If you look to your left at the diagram, the star is invisible from A, but always below the horizon. Star is visible from B. Eratosthenes made the first measurement of the Earth's size. He obtained a value of 25,000 miles for the circumference, a value very close to today's value. He measured the shadow length of a stick set vertically in the ground in the town of Alexandria on the summer solstice at noon, converting the shadow length to an angle of solar light incidence, and using the distance to Syene, a town where no shadow is cast at noon on the summer solstice. Early ideas: distance and the sun and moon size. The sizes and distances of the sun and moon relative to Earth were determined by Aristarchus about 75 years before Eratosthenes measured the Earth's size. Once the actual size of the Earth was determined, the absolute sizes and distances of the sun and moon could be determined. If you're looking at the diameter of the moon and the diameter of the Earth, Earth's shadow, only the part on the moon, is actually visible. These relative sizes were based on the angular size of objects and a simple geometry formula relating the object's diameter, its angular size, and its distance. If you look at the diagram to your left, you can see an isosceles triangle where the angles A and B is equal to 90. And A is obviously an acute angle. And then there's the sun. So you have the sun, the earth, and the moon. Aristarchus, realizing the sun was very large, proposed the sun as center of the solar system, but the lack of parallax argued against such a model. Measuring the diameter of astronomical objects, where L is equal to 2 pi d times alpha divided by 360 degrees. Planets and the zodiac. The planets, Greek for wanderers, do not follow the same cyclic behavior of the stars. The planets move relative to the stars in a very narrow band centered about the ecliptic and called the zodiac. Motion and location of the planets in the sky is a combination of all the planets' orbits being nearly in the same plane and their relative speeds about the sun. Apparent motion of planets is usually from west to east relative to the stars, although on a daily basis the planet always rises in the east. If you look to the diagram, you can see the north celestial pole and the ecliptic, which is the Earth's orbital plane. You also notice Jupiter, Mars, Venus are all gathered about, and the zodiac with the celestial equator. Retrograde motion. Occasionally a planet will move from east to west relative to the stars. This is called retrograde motion. Explaining retrograde motion was one of the main reasons astronomers ultimately rejected the idea of the Earth being located at the center of the solar system. Because of the general east to west motion of objects in the sky, geocentric theories were developed to explain the motions. Eudoxus proposed a geocentric model in which each celestial object was mounted on its own revolving transparent sphere with its own separate tilt. The faster an object moved in the sky, the smaller was its corresponding sphere. This simple geocentric model could not explain retrograde motion without appealing to clumsy and unappealing contrivances. Early ideas: the geocentric model. Moon, Earth, Venus, Sun, Mars, Jupiter, and Saturn. Ptolemy of Alexandria improved the geocentric model by assuming each planet moved on a small circle, which in turn had its center move on a much larger circle centered on the Earth. The small circles were called epicycles and were incorporated so as to explain retrograde motion. Ptolemy's model was able to predict planetary motion with fair precision. Discrepancies remained, and this led to the development of very complex Ptolemaic models up until about the 1500s. Ultimately, all the geocentric models collapsed under the weight of Occam's razor, and the heliocentric models prevailed. Non-Western contributions. Islamic contributions relied on celestial phenomena to set its religious calendar and created a large vocabulary still evident today. Examples are the zenith, Betelgeuse, developed algebra and Arabic numerals. Asian contributions devised constellations based on Asian mythologies, kept detailed records of unusual celestial events. Example: eclipses, comets, supernova, and sunspots, and eclipse predictions. Thank you for watching. See you in class.